Hi, this is John Isles and welcome to Geometer's Paradise. Today we're going to be talking about the second part of the second lesson in Unit 5 using the parallel transversal theorems. Today our objective is to build some short proofs that link together the three angles in a set. So our key is short, but they are going to be proofs. Get ready. Here we go. First of all, a reminder that we have four angle relationships, and that when the lines are parallel, these relationships have meaning beyond what we normally would set. Corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. And consecutive interior angles are supplementary. You can guess where everybody goes wrong, right? Equal, 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 equal. Oh no, but the last one's not equal. They add to 180, so we have to be careful. Alright, so here we have multiple sets of parallel lines. What I want to do here, I have a given that A is parallel to B, A is parallel to B, and that T is parallel to S. I want to list all the angles congruent to angle 1 using only corresponding angles. So here's angle 1. So what angles correspond to 1? Angle 9 does. 9 is in the same position as angle 1. So angle 1 is congruent to angle 9. Alright? And then angle 5 is also in the same position as angle 1. Angle 1 is congruent to angle 5. But angle 13 is also congruent to angle 9 by corresponding angles and to angle 5 by corresponding angles. And that means that we can connect, so angle 5 to angle 13. We could also go angle 9 to angle 13, and look, we've got a setup for a transitive property. 1 to 9, 9 to 13, angle 1. Okay, hang on one second here, guys. My pen just decided to be a stinker. So angle 1 is congruent to angle 13 by the transitive property here. Alright, we can make a connection here through the 9s, or I can make a connection here through the 5s. Both of them are transitive and gets us 1 congruent to 13. Alright, 1's also congruent to a lot of other angles, incidentally. 1 is congruent to 4 by vertical angles. It's congruent to 12 by alternate exterior angles. It's congruent to 8 by alternate exterior angles. It's congruent to 16 through 8 or 12. Alright, so it's actually congruent to all of those different angles for various reasons. Alright, so let's write our first little proof here. Now we're going to use something called a T-proof. A T-proof works like this. We make a T on our paper, and we write statements, things that we know to be true, on the left-hand side, and we provide reasons why we know those things are true on the right-hand side. And typically we number them. So our first statement is, so we want to show that 1 is to 16. So we want to get from here to here, and we're going to go through 9. So 1 to 9 is a corresponding angles theorem. Alright, 1 to 9 is corresponding angles. So angle 1 is congruent to angle 9 because of the corresponding angles theorem. Alright, so now we're going to go from 9 to 16. To go from 9 to 16, we're actually going to cross over the transversal. So this is on the outside. When S is the transversal, you got to ignore this stuff over here. 9 is actually an exterior angle on this line. Okay, and so is 16. So angle 9 is congruent to angle 16. This is the alternate exterior angles theorem. Finally, we can connect the two. We can say that angle 1 is congruent to angle 16 by the transitive property. Alright, so that's our first proof there using the parallel transversal theorems. Let's do another one. So not much has changed, but our setup is different. We're going from 5 to 12. So we want to go from 5 to 12. We're going to go through 4. So we can almost build the proof ahead of time. We're going to 4 here. These are alternate interior angles. And then we're going 4 to 12 straight through. This is a corresponding angles postulate. Wow, that's bad. Okay, let's just pretend that never happened. Okay, still bad. It has to do with the angle that this is sitting on my lap. There, that's slightly better. Statements on the left, reasons on the right. Number 1, we go from 5 to 4. Angle 5 we know is congruent to angle 4 because these are alternate interior angles. This is the alright theorem. Alright. And then from 4 to 12, angle 4 is congruent to angle 12. Alright, and this is by the corresponding angles theorem. And then we can connect 5 to 12 through 4. So angle 5 is congruent to angle 12 by the transitive property. Alright, so there's our theorem, there's our proof. Okay, next. Ooh, look at this one, this is different. Okay, let's trace the connections here. We want to get that angle 1 is congruent to angle 3, but how do they connect? Let's look. I go 1 to 2. I stayed inside the lines, okay? It's only corresponding if it goes over a line. This one doesn't go over the line. This is actually a consecutive interior angles theorem. Alright, and then I'm going to go 2 to 3 the same way. This is another CIA. Now, what do we remember about CIA? It's different from the other 3 because they're supplementary and not congruent. So we have to keep that in mind. Okay? So 1 to 2 is consecutive interior. That means that angle 1 plus angle 2 is equal to 180 by the consecutive interior angles theorem. We also know that angle 2 plus angle 3 is equal to 180. This is again by the consecutive interior angles theorem. Now we've got to do some algebra. Alright, I'm not sure I have enough room for this. But here's the idea. This is equal to 180 and this is equal to 180. So I can connect these two. And I can say that angle 1 plus angle 2 is equal to angle 2 plus angle 3 by the substitution property of equality. Oh boy, substitution, okay. That was a lot of T's, I got confused. So in my last statement I'm going to subtract out the 2's. See, check this out. I got an angle 2 over here and an angle 2 over here. They're going to subtract out, so angle 1 is left equal to angle 3 by subtraction. That's almost what we want. So we have to finish this off. We just say that they are congruent. Angle 1 is congruent to angle 3 by definition. We define congruence as being when two angles are equal. Here two angles are equal. That makes them congruent. So this proof is more involved, 5 steps instead of 3, but still a simple proof. Alright, I forgot to change the numbers. I'll have to do that after we're done with the video here. Okay, so now we want to connect 5 to 11 and show that 5 plus 11 is basically supplementary. Didn't actually say it in so many words, but that's what's going on here. Alright, so statements, reasons. Alright, let's build our connection. We're going to 11 through 13. So this is corresponding angles, and this is consecutive interior angles. So statement 1 is that angle 5 is congruent to angle 13 by the corresponding angles theorem, or the corresponding angles postulate, depending on which teacher you're talking to. And then angle 13 plus angle 11 is equal to 180 by the consecutive interior angles theorem. Alright, that's cool. Now, what's going to happen here next is that we're going to take 13 from here and 13 from here, and we're going to make a substitution. Basically, angle 5 can come down here and replace 13 by substitution, because congruence means equality. I didn't actually write it down, but from this we know that angle 5 is equal to angle 13. So angle 5 plus angle 11 is equal to 180 by substitution. And that's actually done. Now, if we wanted to, we could change this proof and have a fourth line that says angle 5 and angle 11 are supplementary angles. Alright, because of the definition of supplementary angles. Okay, we know that supplementary angles sum to 180. So that makes 5 and 11 supplementary. Now this is totally unnecessary for this proof. It's just interesting information to have. Like it could be added to the proof to make it more complex. Alright, that's it. Good luck on your homework.